Hi students, now question number 4. A sound wave is transmitted into a tube as shown in the figure below. The sound wave splits into two waves at the point A, which recombine at the point B. Let R be the radius of the semicircle, which is varied until the first minimum. Okay, first minimum is the hint given here. Calculate the radius of the semicircle if the wavelength of the sound is 50.0 meter. So understand this problem carefully. So we have studied in the theory interference of sound. When sound traveling through one pipe splits into two paths and again meets at some other point, it may undergo constructive interference or destructive interference. So it depends upon the path difference. Like that, here the sound is entering through the opening A. At A, there are two paths. One is straight from A to B through C. So that path is A, C, B. Suppose if R is the radius of this semicircle, then the sound traveling along the path ACB is traveling twice the radius. Is it not? That is equal to what? The diameter. Another portion of the sound is traveling through a semicircular path. That is ADB. So this path ADB must be equal to what? Half the circumference. So 2 pi r divided by 2, that is equal to what? Pi r. So the portion of the sound traveling along the straight line path travels a distance equal to 2r, and the sound waves traveling along the curved path ADB is traveling a distance equal to what? Pi r. If the path difference is integer multiples of wavelength n lambda, then constructive interference will take place at the point B. But here first minimum is formed. Maxima is due to constructive interference and minimum intensity is due to destructive interference. So here destructive interference is fulfilling the condition what? Path difference is equal to n times lambda by 2. Is it not? So that is the hint they have given. Okay, now let us find out the path difference. Okay, the path ACB, the path ACB is equal to 2r. Then the path ADB, is equal to pi into r. Semicircle. Therefore, path difference. So the path difference, this is equal to the semicircular path pi r minus 2r. So this is equal to r into pi minus 2. This is the path difference. Okay. Now for minimum intensity, that is due to destructive interference. The minimum intensity, for minimum intensity, this path difference must be equal to half integral multiples of lambda. So path difference must be equal to n into lambda by 2. Here for the first minimum n is equal to 1. So here n is equal to 1. So this is equal to, therefore path difference is now equal to lambda by 2. So we will call this as the first equation and this is the second equation. So path difference in terms of radius, it is r into pi minus 2. In terms of the condition for destructive interference, path difference is equal to lambda by 2. Okay, so we are going to equate these two. Therefore from 1 and 2, I write r into pi minus 2. So this is equal to lambda by 2. Now what is the wavelength given? Lambda. Wavelength of the sound is 50 meter. So I am going to substitute 50 by 2 is equal to what? So this is equal to, or this implies R into 3.14 minus 2. So this is equal to 50 by 2, that is equal to 25. We need only the radius now. So calculate the radius of the semicircle. So we want only radius. Therefore, the radius R is now equal to 25 divided by 3.14 minus 2 is 1.14. So this is a 1.14. So this is equal to 21.9. Therefore, the radius is now equal to 21.9 meter. So this is the expected answer. So my dear students, here what is the concept used? So it's a brilliant question, okay. So such problems may be asked in the competitive exams like NEET and JEE entrance also. So here the sound is entering through the point A and then splits in two paths. So there is some path difference. If the path difference, suppose in the same case, first maximum had they given. If they have given maximum means, then we should assume the condition here is what, n into lambda. So minimum they have given. Therefore, the path difference is equal to n into lambda by 2. So by substituting now, we have got the radius is equal to what? 21.9 meter. I hope you must have understood well. Fine.